is from Mark Marron from the University of Kentucky, who will be talking to us about a programming language for data and configuration. Is that right?
You got it.
Okay, take it away, Mark.
All right. So I'm very excited to come talk about this. I loved the keynote this morning. It's set up beautifully for this because we're going to talk about a programming language for data configuration. I was going to put and APIs on there too, but it was getting a little lengthy, so we'll stick with that. So, is data a boring problem, right? Like, I mean, programming languages are about application logic and all this cool stuff, and data, well, I mean, it just like, kind of sits there, right? And how many problems can data really cause? It's simple, right? Application logic is where all these crazy things happen. And, don't we have a bunch of standard representations? We got JSON, YAML, XML, right? That's, put the data in there, everything's great. Well, not quite. I want to tell you how exciting data is, right? It's the heart of a company, right? The most valuable asset in many companies is the data they have and their ability to extract value from it. And oftentimes, it's sensitive or critical to our everyday lives, and we're getting increasing pressure from regulatory and other bodies, putting constraints on how this data is used, spread, tracked, and everything, right? You can imagine stuff like customer and sales leads, critical. Like, I'm a CRM company. That's my moneymaker, is these leads. Obviously, medical history. I'm very sensitive about how my medical data is stored, moved around, who has access to it, right? And I'm going to, just a little cliche, but we're literally in the information technology sector. It's in our name. Companies need to know what they have, where it is, and how it's used. This is a fundamental problem. So now that I got you excited about that, let me point out a few practical impacts of data errors. So in 2020, Citibank got fined around $400 million for poor data quality practices and denying people some loans based on corrupt and incomplete data. And they were put under a consent decree that they needed to fix this post haste. Well, 2024, this summer, the Office of the Comptroller of Currency also assessed another $75 million penalty for not making enough progress to address these problems, specifically the impact of data quality concerns on regulatory reporting. So big money in data, right? I'll also point out another $150 million fine against Twitter for taking phone numbers that people gave for two-factor authentication to do advertising. Now, not only is this a big monetary fine, but you have a big impact on brand quality and customer retention. People get really annoyed about these kinds of things, right? And it's kind of funny, probably everybody's seen this a bunch, but it happened just a month ago. Okay, 8.5 million computers put in a boot loop, grounding a bunch of flights, disrupting the NHS, and a bunch of other stuff for a couple of days. Now, there were many things that went wrong, but what was one of the culprits? It was a custom data format with a custom parser forgetting to do a little data validation and taking 21 fields and cramming them into an object allocated with 20 slots, right? And bad things happen when you stick that extra field on the end, right? So big practical impact. And you say, well, okay, maybe they were using the wrong thing. Maybe we should use X, then, but they already do, right? A lot of existing formats, they're imprecise or incomplete. A fun problem for everybody. Take a 64-bit int and put it in JSON. It's a fun encoding problem. Schema programmings don't map to a language representation, and you still have to do a lot of parsing. And if you're doing stuff, some people use Java, some people use C, and you're putting everything in XML, everybody still needs to parse that XML and put it in their own internal representation. And if you have teams that are producing a lot of data and want to collaborate, this one's using JSON, this one's using XML, you don't care about how the data is represented. You care about it as a logical entity. And a big one that really is a surprising addition is a lot of domain requirements aren't just structural. You have these logical and expression requirements as well. Sometimes field A is null, implies field B has some particular expression. It has to be positive or something else. So it's not just I need to define the structure of the data, but I need to define a lot of logical relations on the components of the data to ensure validity as well. Now, I'm going to say these problems are solvable. And the great thing is, we already have the tools to solve many of these problems. Type systems are designed to describe logical, compositional structures of data. They allow composition, inheritance, building structures up of subcomponents. We have error detection. The great thing is now you can do versioning, right? You don't need to know was it version 1 of the data, version 2 of the data, version 3 of the data. We already have that, wrapped up in package management, all this great stuff. So it really comes down to how do we apply a lot of good techniques we have from building a type system for PL to building a type system for a data model, data language. And there are a couple of interesting subtleties here. So one thing is, we don't want to pick up the nuances of one particular programming language. We don't want this to be a data model for C++, or we don't want this to be a data model for JSON. So it should be polyglot. Like if I'm building a system that talks Java, JavaScript, and Haskell, they should all be able to talk in the same data format. We need an expression language for validation. It's kind of an interesting little bit to tie into this type system. And it's a funny thing. For all, I'll complain about JSON, like in its many quirks. It has an amazing success story of making it easy to author literal data and use this for configuration, test cases, just using curl to test a REST service, human readable, it's great. So we'd like to build on this and have a very uniform encoding that doesn't have all those quirks, but gives us this nice, easy, malleable, interactive way to work with data and systems. So how do we go about doing this? Let's walk through an example. I'm not going to go into the nitty-gritty, but I just want to give you the flavor of some of this. So I went to the National Weather Service, and they have a cool RESTful API where you can send it a location, and it will send you back a forecast for your current location. And I've simplified this. I mean, there's a lot more there, but it has like a low temperature, a high temperature, a field called wind speed, a forecast percent. And you might look at this and say, well, this is the National Weather Service, so everything is going to be in US units, so it looks like a very cold day, but you might have not noticed that, well, hey, actually it has an extra field called units, which may or may not be present, and in this case it says it's SI, so it's actually going to be a very hot day. So, if you're just using this swagger style of let me give you some example records with some sample fields and you can kind of intuit what they are, it's very easy to shoot yourself in the foot and have some bad experiences. So let's convert this from just this random record and examples. Let's actually make this a type. Oh, sorry, let me show you one other funny thing just to give you the real flavor here. National Weather Service has also started rolling out an open API spec, which is a very popular way to specify RESTful services today. And I just took a page, it's a little bit, it's 6,000 lines of code with lots of stuff where it has some description and some other stuff and, all this good thing. But I want to point out a couple fun little bits. So first off is it has a thing called end time, which is given as a type of a string, but its format is a date time. So rather than actually having a date time as a logical thing you can parse, it says give you a string and now you're responsible for parsing the date and the time correctly. It's an ISO format, but good luck getting that right. So all this adventure, everything turns into a string on the web. Another funny one, okay, it's got a name, which is a string. Oh, but it says this value isn't present sometimes. So it's not really a string, it's like a string or null or an option string, but you wouldn't know that unless you read the comment. The other thing is, here's an example of what this string could be. Tuesday night. Okay, so is this like, could this really be any string, right? Could this be is this like some Tuesday, day of the week followed by day-night string? Like, who knows? You just, you kind of guess. Maybe you curl a bunch for a little while until you feel lucky and you're gonna make up your mind on what it is. But no, we want a much more concrete, analyzable, grounded thing. So here's our definition of this forecast in our Bosky data description language. And now let me be really upfront. This has kind of been a project that I've been working on with some great folks in the fintech sector and at Microsoft, and we've been swapping ideas around. So there's a couple cool projects with a lot of the same flavor. But this is the particular one that we took as kind of the greenfield North Star. We're going to go and we're going to take the idea as far as we can without necessarily a lot of practical concerns. So as you can see, it looks just like a class definition, right? And we can do inheritance for composition. We have enums, we have numbers, we actually have real floats and real ints and all this good stuff. And then we can declare an API as a special type of function that's going to get exposed as an endpoint. So this already improves on it a lot. Now we have a concrete thing with fixed semantics and we can reason about it. But we can start doing a little bit better, right? An easy table stakes one is to allow type alias declarations. So this is like a new type. So we can say, hey, temp range isn't just an int, it's a Fahrenheit, and we're actually going to put that in there, and then you won't get your Celsius and your Fahrenheit confused just as type structures. This is great. But we can start being more fun. Like we care about data validation and data quality. So maybe I have forecast percent. it's currently declared as a float, right? I could new type that as a percentage, but I'd also like to be able to new type it and then enforce some constraints on it so that it should always be greater than or equal to 0, always less than 100. And we want that to be checked automatically when you're parsing these, importing these, everything. So you don't have to worry about bugs in your parser and validation logic, which are one of the top issues that pop up in web services, kind of unsurprisingly. But let's keep going a little bit more. So we also had these weird sort of structural strings, like there was some semantic information crammed in a string just because it was the same thing everybody talked, but it really had semantic structure. So we want to allow people to express this semantic structure in a precise way. So you can say, here's a const regular expression that is showers, thunderstorms, snow, or fog, easy. And then you can declare, I want forecast detail to be a string of some other regular expression, which you can actually compose these const regular expressions in. So you have a nice composable way to describe, if you have a string, is it truly an unstructured string? Is it a semi-structured string? What's that structure? That structure is reusable and composable across the way. And this turns out to be incredibly, incredibly useful. And I think there's a very interesting opportunity to do a lot more with structured data and string languages to solve more problems than you can do with just regular expressions. Like I said, a big win we have is being able to do logical validation. So of course we can put in some simple preconditions like, okay, don't pass me the empty string for the city name. It should at least contain a couple characters. But you might also have other interesting stuff, like if I get a forecast, the low temp should be less than the high temp, right? And the wind speed min should be less than the wind speed max. And of course, since we're good programmers, we don't want to just put these on an API. We should put these in the typed as validation invariant so that they're enforced everywhere, and it's very easy and obvious that these are checked and are always correct. So then I said we want to have a literal representation. So this is kind of a nice way. We want to make it really easy to author and read these values. JSON is very nice. A couple pain points it has is it doesn't have a good representation for all types. A lot of stuff gets crammed into strings. And there's all sorts of tagging issues. Some people will use tags on the object. Some people will use envelopes. And there's always conflicts in the way it's done. So if we just clean some of this up, we have a really nice way to say, hey, I want to write a forecast value by hand. And we can do it with explicit tagging on the left there. Gives this nice way to say, here's a forecast between 33 and 52. The ints are explicitly tagged as Fahrenheit. So you can read this and understand it pretty quickly without any additional information from the type system. If you have a big document, having to explicitly annotate everything is a bit of a pain. So it's nice to be able to elide this in cases where you know what the type is. So you could just drop the explicit temp range or Fahrenheit parts on these values. So this makes it really easy to author configurations, to use this as a fairly efficient but still human readable data transport format. And its convenient thing is it's still very efficiently parsable. Okay, so hopefully you're like, hey, this is cool. This solves our immediate problem that we have in this data API spec space. We can describe what data a program takes in very efficiently. We don't have to worry about parsing and validation bugs. We have a great literal format we can build to communicate across polyglot services. I think that's super exciting, and a great way to show the value of programming languages in practical problems. But we'd really like to build on this to address other challenges, right? So when I'm setting up a service, I got to deal with testing, I got to deal with mocking, I got to deal with versioning. I'd really like to make it AI accessible, right? So how do we build on this, bringing PL concepts to data to enable some of these scenarios? So I don't have time to dive into all of them, but I'm going to hit 3 that we've sort of done some prototype work on just to give a bit of flavor of this. So let's talk about mocking. So unit testing code that just adds 2 numbers is pretty easy. Unit testing code that does some compiler transforms is harder because you got to do a lot of data setup, but not too bad. What really gets you is I'm now going to do unit testing on my microservice that depends on other services. So let's say I'm going to create a sailboat rental application, and I'm going to check the weather forecast and decide if it's too stormy to rent you a sailboat today. So what do? Well, I either call the National Weather Service as part of my unit test, and now I have a flaky test. I decide to create my own copy of the National Weather Service and put it in some sort of weird sandbox and run it directly. Or I go and I manually write a bunch of mock data, which nobody ever does because it's a huge amount of work and it's always out of date, and then you only test the happy path, right? So this is super unpopular. So instead of doing this, let's use the fact that we have a great structural description of our data as a type. And in this logical language that we have for putting constraints on it, we've conveniently constructed it to be very deterministic and easily encodable to SMT semantics. So now we can ask a solver like Z3, hey, when I'm running my unit test, if I have a value, go and just take that service and generate me a valid response, right? We can tune it for natural values, random values, whatever, but we don't even need an implementation of that service. So here's a quick example. We have that forecast going there. And I'm going to go, I have no implementation. I'm just going to evaluate it with certain inputs. So I'm going to say, hey, I'm going to give you a city name, Albuquerque, and you generate me a forecast that is the right structure, the right types, and all of the constraints are satisfied. I'll give you another one, Phoenix, right? And it'll generate a forecast that has all those constraints satisfied. Now, I'm just solving for a possible solution. So you'll see it's predicting snow in Phoenix, right? Which might not be the most natural solution there, but you could ask an LLM to fill in some of these values and then validate with the solver as well. But this way, I don't actually need a service. I can just execute a service from its spec, plain and simple, right? So this is super cool. Another fun one is AI programming, right? So suppose I have a simple, really simple service, or I'm going to just use a function in this example, that's going to find some pair, and it has a signature, and it has some constraints on it. And really, you know, LLM agents, they don't always get things right the first time. So it's nice to give them a couple test cases, right? And then you kind of winnow out wrong solutions. So you ask the programmer, all right, we got this great literal syntax. Go ahead and write your input-output pair in the examples there, and we'll go and synthesize this body for you. Now, nobody likes writing a bunch of input-output pairs and trying to, you know, kind of scratch their head and think what values are interesting. So let's come up with a different approach. Let's go and actually take this, put in a keyword defer, and we're going to allow you to execute the program. So we'll put a bunch of calls to find max pair in there. You're just going to run the program. There's no implementation. That's cool. We'll just run for a while, and if we hit one of those, we'll pop it up and we'll say, here was the input. Can you write the correct output for that particular function? So okay, we do that. We'll run it again. It's actually got one duplicate input, so it can use a memo table. It keeps going there. Finds a new input. We give it the answer there. And there you go. Now we've got our set of examples all built up, ready for the AI agent to synthesize that. And even the better part was, I could start writing my code, I could start testing my code, I didn't need to implement anything, and now my AI agent can do all that work for me. Building on that, very fun thing is, suppose, you know, I'm now using an AI agent to do some work for me, right? And how is it going to do some work for me? I'm going to expose some APIs that it's going to be able to call. So here's one that's useful, especially if I'm in fintech, I'm doing trades and I need to pay somebody. So I'm going to take some amount of money from in US dollars, and I'm going to send it from an account to an account. Now, would you trust ChatGPT with access to your bank account with this API, right? I mean, it's probably usually statistically going to not wire $10 million to, you know, some strange country where I'll never get it back from, right? But you never know, right? It's a statistical agent. Well, I'd really like to provide some sound guardrails. So the great part is we have this ability to put requires and constraints on what an API does. So we can say, hey, I am going to demand that under no circumstances will the amount ever be larger than payment limit. So I will put a hard guarantee on how much this agent could ever transfer. I could also add other things like I must have maybe a valid bill the to account must appear in a valid invoice in order to make a payment. I can put other things, but I can put a concrete semantic guarantee that this agent will never violate this property, right? It's not just a statistical guarantee, it's a well-founded guarantee. Interestingly enough, there are other things you can do. So I might want to allow an AI agent to schedule meetings, right? So I'll say, hey, you can schedule a meeting on my calendar. You give me a time, you give me a list of attendees. It's all great. Now, in theory, maybe scheduling a meeting at 4 a.m. on Saturday is cool. Maybe that's the right thing for it to do. But in practice, I probably don't want that, right? So what I'd really like to do is be able to put a soft check on that API and say, like, look, you can schedule a meeting at 4 a.m. or outside my working hours if you want. But if you do, I want at least to be able to verify that that may or may not happen. If it does, I may want to take some action, like reconfirm with the user, do you really want me to schedule this meeting at 4 a.m.? Or re-rank possible solutions for one that doesn't pick such an odd time. So what's the conclusion here? Well, hopefully I showed you some exciting stuff, but I think data configuration, API specification are actually really critical issues in software systems. And they often get overlooked in the programming language community because they're not that core logic, but we have a ton of tools that apply really well to them, right? Data is the foundation of computation, and parsing and validating is surprisingly hard and buggy, real common source of errors. So, and I think, in the second half, hopefully I showed you that improving and semantically grounding some of these things actually opens some amazing opportunities and advances in other areas, right? Testing, traditional software engineering, but also allows us to have a real voice in this sort of exciting space of how LLM agents are growing and being put together. And in particular, this notion of verifiably trustworthy agents, not just statistically trustworthy agents. So I'll close out, just got a couple links here. We got some projects up there. An interesting paper we did with some folks on, programming and these data issues in the fintech area. And I also want to thank some of my key collaborators, Brian, Stephen, and Richard, right? It was great to get their input on this, and they really had a big impact. So I think that's it for me, and I hopefully have a couple minutes for questions.
Thank you, Mark. If anyone has a question, please step up to the microphone. And if you could give it a quick tap to check that it's on, I would be very glad. Perfect.
Hi, thank you. That was really, this looks great. So I often get very frustrated because I have I'm writing types and I'm writing validators separately, right?
Yes.
Within web development, usually like with Zod or something.
Oh, okay, yeah.
Right?
Yeah.
And, but sometimes that feels annoying, but sometimes that feels kind of right to me, to sort of have this like separation. Like, can you, I was wondering if you could talk more about like what your view is on that. Like, do you really want them all together all the time, or yeah, how do you see this?
Well, I think this is the interesting, this polyglot world, right? You really want to have a central point of truth about what a user is or what an account is. And then from that, you want to be able to generate the appropriate types in the languages that your system consumes, right? Like, you'll want to be able to generate those representations for SQL database. You'll want to be able to generate those representations for, a RESTful API. You want to be able to generate Java types from them. So I think that's really this separation of what is our logical model of data, and then what's the physical version everybody consumes. So I think that's kind of the way I view that splitting, right? If that makes sense.
Yeah, so it's like something like higher up, perhaps.
Yes, and let me focus. So yeah. Brian Turleson is working at the Azure service where they have this problem where they're building SDK, they have one service, and they're building SDKs for it in a bunch of languages, and they have a bunch of versions in each of these. And it's like, we do not want to try and keep all of these and maintain. We need a central point where it says, this is what the service does. Everything else flows from that, and we have guarantees that they're all consistent, right? Nobody likes making a call in Java and the same call in JavaScript, and they don't work, right? Because of some parsing difference or bug.
Thank you.
Hi. Thank you for taking on this problem. This is something I've fretted about for a long time. We have long had the situation that the programming language algorithms strain of programming and software engineering has shouted out the data representation portions. And this, this came fresh to my mind a few months ago when the CrowdStrike outage happened, that it was so much related to data, and the company was in fact in their initial report saying, but it was only data. So previously I had a run at this and didn't make any progress and gave up and went away. But a long time ago, when I thought about having a run at it, I looked at the specs for the standards for electronic data interchange. And one of the reasons that I shied away from it is because they were so complex. There were layers and layers of complexity. There were whole fields that were dependent on the values of other fields. So my question is, how far into the complexities of serious EDI do you go? Are there things about EDI that cannot be described in regular grammars? Is it just a matter that it's complicated, or is there some deeper semantic complexity?
So I think in this one, the goal here is to create, it's just like a programming language type system. The goal is to make it easy for separate teams to develop logical models for their data and then exchange, compose, and version these effectively. Now, one of the issues is you won't be able to generate from these physical models for encoding this data. I'll swap you out. Now, one of the things is you're not going to be able to generate as efficient an encoding as, let's say, if we were doing this from gRPC, right, where your definition is closely intertwined with the physical encoding. It's just like working with Java versus C. Well, I can squeeze out more performance in C because I can twiddle individual bits. In 99% of cases, it doesn't matter. For these RESTful services, they're much more concerned with correctness than getting that last 1% of performance. So I think this is a place where we trade off some of the complexity for general simplicity and reliability and usability.
So you're saying that the real issues that arise out of commercial grade EDI are issues of efficiency rather than efficiency of the ability to represent?
Yeah, that's how I'd frame it. Yes.
Thank you.
Yeah.
Thank you. I have to be a really brutal session chair and cut the questions here, but I'm sure we can take them offline.
Okay.
Let's thank Mark once again.